Here in this question, a grammar a grammar is given, and we have to identify the useless productions from the given grammar. So if you see the grammar, we can see that non-terminal C cannot derive any terminal. So this production is useless. This entire production is useless. If this production is useless, we cannot reach non-terminal C from starting symbol S. So even this production is also useless. If these two are useless, and here we cannot even reach D, non-terminal D, from starting symbol S. So even this symbol, this production, D gives D, 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 is also useless. So total there are three useless productions. So which is option D.
Let H be a subgroup of group G, and H and BH are two left cosets of H in G, then which of the following is true? Option A, H and BH has some elements common. H and BH are always identical. We can say this is statement. Option B is false. H and BH are always disjoint, and even this is also false. And option D, H and BH are either identical or disjoint. Here this option D is true. Why? Because let us suppose they are disjoint. If let us suppose they are not disjoint, that means uh, some common element will be there in both H and BH. That means X belongs to AH and BH, intersection BH. X is equal to AH1. Let us suppose X is equal to BH2. So AH1 must be equal to BH2. From this we can write A into H1 H2 inverse is equal to B. Why? Because here as they are groups, inverse exists. So here we can say AH3 is equal to B. It implies B belongs to AH. And the same way we can prove that A belongs to BH. Implies AH is equal to BH. That means if they are not disjoint, then those two are identical. So here we can say that either H and BH are either identical or disjoint, which is option D.
A block addressable disk with following characteristics: size of track 20,000 bytes, non-data overhead per block is 500 bytes, and record size is 100 bytes. How many records can be stored per track if blocking factor is 45? So here blocking factor is equal to number of records stored in block. Blocking factor is number of records stored in block, that is given as 45. What is the one block size? That is 4,500 plus 500, that is 5,000. One block size. Because non-data overhead per block is 500 bytes. Then number of blocks per track. Number of blocks per track is equal to 20,000 divided by 5,000, because one block size is 5,000. So this is equal to 4. So records per track is blocking factor 45 into 4, it is 180. So this is 180 is the number of records stored we can store in a track. is B. Number of states required for DFA to recognize the regular expression 0 of 10 whole star is 2, 3, 4 and none of these. So 0 of 10 whole star will give you the strings 0, 0, 1, 0, 0, 1, 0, 1, 0 like this. You can have the DFA like this. Minimum string is 0, you have to go for a final state. Then after that 1, 0, 1, 0, 1, 0 will be accepted. We have to introduce a dead state. Dead state also must be considered in the number of states. So total 3 states. B is the right option here.
Which of the following is true for a simple graph with V vertices and E edges? Here 4 options are given. Here chi of G is nothing but chromatic number and I is the independent number of the graph. As the independent number is I vertices will be I vertices are not adjacent. So for all of those we need only one color, and for the remaining vertices the maximum number of colors would be V, and if we include that particular one color for all the I vertices, then chromatic number will be maximum of V minus I plus 1. This 1 is added. Why? Because one color, we need one color for all the I vertices which are independent. So this is the relationship between chromatic number and vertices and independent set. So here correct option is option C.
Set of instructions. I1 is R1 to R2 plus R3. I2 is R4 to R1 plus R2. I3 is R5 to R1 star R4. Assume data forwarding is used and the time taken for each instruction stage is given like this. Number of clock cycles. I1 is 1 to 2 1. I2 is 1 to 1 2. Fetch, decode, execute and write. I3 is 1 1 to 1. What is the number of cycles required to execute the above instruction? So let us write the clock cycles here. 5, 6, 7, 8, 9, 10, 11, 12 like this. So instruction 1, for fetching 1 cycle required, for decoding 2 cycles, for execution 2 cycles, then writing 1 cycle. Again instruction I2, fetching should be 1 cycle. Again decoding we can't perform here. This is decoding, and then instruction I2, that is the result of the I1 is depending on execution of I2. So without getting R1 value we can't use it. So by this, after decoding, if you want to execute, as the operating forwarding is available, so we can make it available before writing, so that we can do execute. For execute it takes 1 cycle, for writing it is 2 cycles. Again I3, fetch can be done here 1 cycle, decoding we can't perform here, execution we can perform because operand forwarding is there, writing can be done here. At 9th everything will be over. 9 cycles are required.